In this lesson, you will learn how to solve word problems involving velocity and acceleration. Velocity is found by taking the first derivative. It is a measure of how fast the position is changing. So the position function s of t, take the first derivative to find the velocity. The speed is the absolute value of the first derivative. Acceleration is found by taking the second derivative, or the first derivative of the velocity function. Acceleration measures how fast the velocity is changing, or another way to say that, how quickly the body loses or picks up speed. So acceleration is found by taking the second derivative of the position function, or the first derivative of the velocity function. For number 1, a particle moves along the x-axis so that its position at time t is given by s of t equals 3t to the third minus 40.5 t squared plus 162t for t between 0 and 8. So first I'm going to write the position function s of t. And then underneath, before I calculate parts a through f, I will find the velocity function v of t, which is just the first derivative, 9t squared minus 81t plus 162, and then the acceleration function is 18t minus 81. So now let's take a look at part A. Calculate the initial velocity. The initial velocity is found using the velocity function at the original time, which is t equals 0. So to find the initial velocity, I take v of 0 and substitute it into the velocity function. So that I get 0 minus 0 plus 162, so the initial velocity is 162. For part B, when is the particle moving to the right? The particle is moving to the right when the velocity is positive. So I take the velocity and set it greater than 0. So the velocity function 9t squared minus 80 So the velocity function 9t squared minus 81t plus 162 is greater than 0. And if I divide all of the terms by 9, I have t squared minus 9t plus 18, and I would change the inequality symbol to an equal sign so that I can factor. So at time t equals 6 and t equals 3, are the points that I place on the number line, and since I want the velocity to be greater than 0, To be greater than means that the values are not in between the 2 points, so we would say that the particle is moving to the right when the time is less than 3 or if the time is greater than 6. For part C, when is the particle moving to the left? That is when the velocity is less than 0. So when I take the velocity function and set it less than 0, it's the same as part B. T squared minus 9t plus 18 equals 0. T is equal to 6 and t is equal to 3. So when I place these points on a number line, since we're looking for values that are less than 0, less than, the values are in between. So the particle is moving to the left between 3 and 6. So 3 is less than t is less than 6. For part D, when is the object decelerating? That means when is the acceleration decreasing? So I will take the acceleration function and set it less than 0. So a of t will be less than 0. So I take the acceleration function, 18t minus 81 is less than 0, and I solve for t. So when an object is decelerating, it means that the speed is decreasing. So t is less than 4.5. For part E, when is the velocity not changing? That means that the acceleration is equal to 0. So I will take the acceleration function and set it equal to 0. So 18t minus 81 equals 0, and I'm solving the same equation that I solved in part D. The only difference is that now I have an equal sign instead of a less than sign, so t is equal to 4.5. So before 4.5 seconds, the particle is decreasing. at 4.5 seconds, the speed is not changing. And then the last part, part F, if we move up above, asks for when the object is accelerating. That means the acceleration will be greater than 0. So I take the acceleration function and set it greater than 0. And when I take 18t minus 81 is greater than 0, the answer is t is greater than 4.5. For number 2, a particle moves along a straight line so that the position at time t is given by s of t equals t squared plus 4t plus 4. What is the acceleration of the particle at t equals 4? So we will be finding a of 4. So if I write the position function s of t, t squared plus 4t plus 4, and then I find the velocity function, which is 2t plus 4, and then the acceleration function is just equal to 2. To find the acceleration at 4, I cannot substitute 4 because the acceleration is always equal to 2. So the particle has a constant acceleration regardless of the time, so the answer is 2. For number 3, a particle moves along the x-axis so that at time t its position is given by x of t equals t cubed minus 6t squared plus 9t plus 11. So x of t is the position, which is the same as s of t. So the position is s of t, the velocity is 3t squared minus 12t plus 9, and the acceleration is 6t minus 12. So I always find the three functions and label them on the side, and then I go to the actual parts of the question. Part A, what is the velocity of the particle at t equals 0? So we are finding v of 0, which is the initial velocity. So I take 0 and substitute it in for t in the velocity function, and the velocity at time t equals 0 is equal to 9. For part B, during what time intervals is the particle moving to the left? If it's moving to the left, that means that the velocity is negative or less than 0. So we take v of t and we set it less than 0, so that 3t squared minus 12t plus 9 is less than 0. So to solve this, I divide everything by 3, and I have t squared minus 4t plus 3 is equal to 0. When solving a quadratic inequality, I always change it to an equal sign, and this factors to t minus 3 times t minus 1. And when you set both factors equal to 0, you have t equals 3 and t equals 1. So when I put these points on a number line, I have 1 and 3. And since this is less than means that you shade in between the points. So that means the particle moves to the left between 1 and 3. So 1 is less than t is less than 3. For part C, what is the total distance traveled by the particle from t equals 0 to t equal 2? To find the total distance traveled, we use the position function, s of t. So from 0 to 2, we will take s of 2. So I substitute 2 in for t, so that I have 8 minus 6 times 4 plus 18 plus 11 and 8 minus 24 plus 18 plus 11 is equal to 13. So the total distance traveled is 13. For number 4, a rock is launched in the air with the launch velocity of 160 feet per second. The launch velocity of 160 feet per second is the initial velocity. So that means that v of 0 is equal to 160. It reaches a height of s equals 160t minus 16t squared feet after t seconds. So before I get to parts A and B, the position function s of t is equal to 160t minus 16t squared. The velocity is the first derivative, so it's 160 minus 32t, and the acceleration is the second derivative, which is minus 32. So for part A, what is the maximum height of the rock? This equation, the position function, 160t minus 16t squared, is parabolic, and it's a parabola that points down. So when a rock is launched in the air, it makes a parabolic shape pointing down. So when it asks for the maximum height of the rock, we are looking for this point here. And the maximum height of the rock is a point where the first derivative is equal to 0. So the first derivative, if we set it equal to 0, (160 minus 32t), this will tell us how many seconds it took for the rock to reach its maximum height. So if I solve for t, I get t is equal to 5 seconds, but part A is asking for what is the maximum height of the rock. So we know that it took 5 seconds for the rock to reach its maximum height. So to find the maximum height, I have to use the position function. So this question has two parts. So once I have t equals 5, I now find the value of s of 5 by substituting 5 in for t in the position function. So the maximum height is 400 feet. For part B, how fast is the rock traveling when it is 256 feet above the ground on the way up and on the way down? So we know that the maximum height is 400 feet. So when it is 256 feet above the ground, it could be at this point, approximately, or this point. Since the rock is going in the upwards direction, here the velocity will be positive, and since the rock is going down, the velocity will be negative. But since we're finding out how fast the rock is traveling, we are finding the speed. And the speed is the absolute value of the velocity. So I take the velocity, so since 256 is a height, I take the position function s of t and I set it equal to 256. So 160t minus 16t squared is equal to 256, and I want to solve for t. So if I write this in standard form, negative 16t squared plus 160t minus 256 equals 0, and I divide everything by negative 16, I have t squared minus 10t plus 16 equals 0, and this factors to t minus 8, t minus 2. So at 8 seconds and at 2 seconds, the rock has a height of 256 feet. So the first one is 2 seconds, and the second one is 8 seconds. So the question is asking for how fast is the rock traveling. So I take the 2 times t equals 2 and t equals 8 and substitute them into the velocity function to find their speed. So I take v of 2 and v of 8. So I have 160 minus 64, which is equal to 96. So 96 feet per second is the speed on the way up. And for v of 8, I take 160 minus 32 times 8, which is 160 minus 256, which is equal to negative 96. So since we're finding how fast, which is a measure of speed, I have to take the absolute value, which is again 96 feet per second. So the negative just indicates that it's moving down, but the speed is 96 feet per second. So if we look at the picture, at 2 seconds it is traveling 96 feet per second, and at 8 seconds it is also traveling 96 feet per second, but at 2 seconds it's going up, and at 8 seconds it's going down.